I'm Tiphaine, and I'm analyzing historical documents and imaging them with a cutting-edge technology called terahertz time-domain imaging. This technology is provided to us by our partner TeraView, and I'm also benefiting from the expertise of conservators from the National Archives of the Netherlands. This is a 2,000-year-old scroll, and it contains the oldest known Buddhist writings. But to uncover these writings, conservators from the Library of Congress had to physically unroll the document by gradually humidifying it over several days. Could we read through such document without opening it? And yes, we can. Researchers have been using X-ray technologies to scan scroll and then virtually unroll the scans of the scroll and reveal the ink inscription within the document while the actual physical scroll is still in its rolled state. But researchers have also realized that you can actually only reveal really well these ink inscriptions if the ink contains metal. And if you try and do an X-ray scan of this carbonized scroll from the Herculaneum site in Italy, you'll realize that when you virtually unroll it, on the X-ray images, there's nothing to be read. And researchers believe that is because the ink that was used to write this manuscript does not contain significant amount of metal. And indeed, historically, many inks were not produced from metallic compounds, including the ink that was used for some of the Dead Sea Scrolls, apparently. This is an inkwell that was found in the same caves as some of the scrolls, and it contains a black ink, which is vine black, the soot of burned vines. No metal here. There's no need to go as old as the Dead Sea Scrolls to find documents which were not written with metallic ink. Prints, typewritten documents, they were written with an ink that contains organic dyes, carbon particles, and you find loads of these in archives, and they do not contain metallic ink. And indeed, they degrade much faster than the 1,000-year-old scroll sometimes. I'm passing around this book, which is less than 100 years old, and you'll see that it's already very difficult to turn its pages. Perhaps in 100 years' time, we won't be able to read it. Is there a non-invasive technology, an alternative to the existing X-ray technologies that could still read through documents, but also reveal these inks that are not metallic? That's when terahertz time-domain imaging comes into play. Some of you might have heard the word terahertz before. It's a technology that's been used a lot for security applications, again, as an alternative to X-ray technologies. In the airports, for example, to detect drugs, explosives, ceramic knives in luggage, all these things that are not metallic. Now, terahertz, the word terahertz specifically, refers to invisible waves that have a lower frequency and therefore a lower energy than our visible sunlight. Now, how does in-depth imaging of a document with terahertz time-domain imaging works? It consists in sending a very short pulse of terahertz waves onto your document. Every time the pulse meets a new material, like the ink or the paper, the pulse gets partially reflected, partially transmitted through the layer. And it's a bit like the echo of your voice in a cave. The deeper the layer, the longer it will take for the pulse to be reflected back where it came from. So if you only select pulses with a specific time delay, you can reconstitute an image of the layer they were reflected from. We say it's suspected to be a non-invasive technology because if you send this terahertz pulse onto a very absorbing material like water, there's barely any heating observed on the surface of the water. But still, before I go on and play around with invaluable documents from the archives, I first need to know what terahertz waves are sensitive to. Are there pigments and inks that reflect more terahertz waves? Does paper reflect more terahertz waves than parchment? So to do this, in the laboratory, I've prepared lots of different inks based on historical recipes, and I've applied them on paper and parchment sheets, and I've imaged them with terahertz time-domain imaging to see which ink on which support gives the best contrast on my terahertz images. But then I want to compare my study with my models to the real stuff, but it's still too soon to use archive. So I asked my good friend eBay if it has some old documents that nobody wants anymore that I could use to try and image them with my technology, such as these love letters from 1946. What I really like about the sender of these love letters, Bardon, is that he's writing to Jane with the very same typewriting machine over the summer of 1946, so the same ink, but he's using whatever paper sheet he has at hand. So it enables me to show that the same ink can either show a very good contrast or a very poor contrast on my terahertz images, depending on the support it was written on, depending on the paper. Then you also want to know how deep you can image through a document. Can you image a whole book? No. Okay, how many pages can you image? It depends on how thick and how absorbent each page is. So I've analyzed lots of paper sheets, lots of parchment sheets, and I've actually realized that not all parchment sheets absorb terahertz waves the same way. I think it might be due that the skin that was used for the different parchment sheets does not come from the same animal species. Maybe. Thank you so much. I know that we have lots of building lovers in the audience, so if interested, there's also a group that's doing terahertz time domain imaging of mural painting hidden behind a layer of plaster. Thank you.